All right, I'm going to talk about some of the other components of a shader. So I have just a plane, a ball, and I need a light source. So for this one, I'm going to use, instead of building a whole light rig, I'm just going to use a sky dome. Sky dome is where you can plug in a physical sun and sky. You can also plug in light maps, HDRs. We'll talk about that at some point. Basically, they're useful if you're trying to match your CG image to an existing lighting that you've shot from a live action plate. So let's see here. Let's get this one for now. All right. Save, render, go. All right. All right, so we're gonna, our standard surface. All right. All right, here. So let's just leave this gray for now. All right, so each of these parameters have a weight, a kind of a multiplier of this component of the shader. So let's turn the diffuse off. Let's assign this material. And so every other component at the moment is turned off. So all we are seeing is the specular component of the shader. And specular refers to a single ray, a perfect mirror reflection. Even though this is all under specular, as soon as there's a blurring of the specular, it becomes a glossy kind of effect. And here, let's see here. What if, we'll talk about IOR later, but I'm just going to boost it up so you can really see that component of it, right? So specular is a single ray, mirror image, and as the roughness increases, it blurs the reflection until when the roughness is all the way up, it's something very similar to diffuse, right? So here we have this diagram. Think of a ray, a line coming out of the camera and hitting the geometry. When it is diffuse, the value that's returned, the color on that surface, is a whole 180-degree dome over that. So, okay, hits the surface, sends out a 180-degree dome of a bunch of samples, averages those samples together, and that's the color you get. As the glossiness increases, the dome gets smaller. And this is actually like a two-dimensional thing, but think of it like a cone, right? A big cone here, smaller cone here, and then specular is just one ray in, bounces off it, samples a single point somewhere else. All right. This cone is called a steradian or solid angle. And in fact, the Arnold, the company that made Arnold, their name was solid angle, and it comes from this how big is the cone? And the same thing happens in reverse. So if the transmission, how big a cone of samples is coming into that one point will determine how sharp the refraction is. So let's see here. Let's turn specular off. Let's turn transmission on. Right? And right now, we're actually seeing through the ball like a kind of glass lens. Here, let's put a cylinder back there so we can kind of see what happens. All right, so then we're gonna standard surface, transmission, turn up the transmission weight. There we go. So we're seeing our cylinder. All right. And then as we increase the scatter, the cylinder will get softer and softer. We turn on the extra roughness. There we go. Then we really start to see it. All right. To the point where it's basically coming in from every direction. So the wider the angle, all the way wide is diffuse, all the way sharp, single point is specular, something in the middle is a glossy. All right. Okay, so while we're at it, let's talk about something else. So I'm going to turn over here, turn down the transmission, turn down the specular again. So we have this index of refraction, and different materials have different indexes of refraction. So water's 133, a diamond is 2.5. There's tables online, you can find them, and this is a really good way to start getting the behavior of your material. Metals are really high numbers, see? And the higher the number, the less fall off there is between the front and the side. So watch what happens. If I turn this number way down to like say 1.25, what's going to happen is it's still, this is like car wax. It's shiny on the edge, and as it comes to face the camera, there's almost no contribution at all. Whereas if I turn this number way up, it's shiny here, and it's like a perfect mirror on the side. Now, this also affects the transmission. So how the transmission works is the lower the index of refraction, the less distortion there is through the refraction. The less the effect of the refraction is. It's like a more shallow angle. So if I make it 1, see, it's just perfect. The rays go through, they don't bend, okay? As I turn the IOR up, the rays that hit this ball here are going to bend more and more, and it's going to be more and more distortion in the shape. All right. So as the IOR increases, there's more bending of light in the refraction, more distortion. And as it increases, the fall off from the front planes facing straight to camera and side becomes less pronounced. Lower numbers, less distortion and refraction, and more pronounced fall off in the reflectivity. All right, and the final thing is materials have indexes of refraction that you can look up as a starting point to kind of tune in their behavior.